and I'm here to introduce Ashish Chhabria. And before that, a short intro about me. I am Arun Prabhu, working as a senior software engineer in Serverless 360 team, and I've been a part of COVID.co for past 4 years. And about Ashish, he's a program manager in Azure serverless team specific to Azure Service Bus, and he's going to give a talk about Azure Service Bus. So, over to you.
All right, thank you. All right, can everyone hear me? All right, perfect. Hi, my name is Ashish Chhabria. I'm the PM on the Service Bus team. If you can tell from my blazer, I work on Dan's team as well. So thanks for having me here. It's my first time at Integrate, first time in London, and I finally learned how to accept cookies while browsing the internet. So it's a big deal for me. All right, so we're here for the Service Bus update. What exactly does Service Bus do? Have any of you all used Azure Service Bus or any other message queuing platform? Can I see you with fans? Okay, that's a big audience. All right. Okay, so I will not go too much into the basics of Service Bus. Basically, Service Bus is our enterprise messaging as a service, fully managed PaaS offering that offers point-to-point and topic subscription pub-sub semantics. You can think of Service Bus as a central arbiter of state and truth, kind of moving money or matter between your two decoupled services while allowing them to scale horizontally as needed. The messaging team has a bunch of options for you to pick from, but if you're designing a use case where you know what the nouns are, who's sending the message, what is the message, and where it's going to, Service Bus is the right tool for the job. All right, I'm going to skip through this so that we have more time for the demo and the questions, but basically queues, the basic stuff, sender sends to a queue, the receiver will acknowledge, or the broker will acknowledge it, the receiver will receive from the queue, and then also send out and complete the message, and the queue will essentially broker this conversation. On the topic and subscription side, we have the same semantics, only expanded further. The sender only knows about the topic it's sending to. The receivers know about which subscription they have to receive from, and any message that's sent will be matched against the filter conditions, and depending on where it's where the filter conditions match, it'll end up in that specific subscription. All right, so Service Bus, we essentially have two pricing tiers. So we have our pay-as-you-go model, multi-tenant, which essentially is recommended for dev and test environments, and any kind of low throughput setup as well. And on the premium side, we have, we're essentially setting up an answer to our customer demand for dedicated resources that allow us to give them predictable performance, throughput, latency, and also a fixed pricing model where they can provision message units for their specific namespace, and we charge a fixed price based on that with no overages. So this is recommended for any kind of production environments, high throughput, anything that needs very detailed enterprise features like high availability, disaster recovery, VNets, MSI, RBAC, etc., which we'll learn more about. So now jumping back into our presentation. All right, so you saw the slide before in Dan's presentation as well. Some of these numbers have been updated to showcase Service Bus. I really love updating the slide because I can see how much our growth has been over the past 10 months or so since I've joined. And essentially, we see about 22 billion requests managed by Service Bus per day. And 95 of the top 100 Azure customers actually end up using one of our messaging offerings. And also, Dan spoke at length about our availability, so that's great. All right, so what's new in Service Bus, and what have we shipped in the past 1 year? What's coming soon? What exactly is our update? So there's a lot to cover. I broke them out into 3 streams. There's the business continuity piece, which talks about our high availability offering, our geo disaster recovery, and also enabling you to achieve those goals for your application. So let's dig deep into that first. So first things first, we have reached our core status. So this is really an Azure way of saying that we're in that core level offering for our services within the data center. So a data center cannot go live without having Service Bus on it. So we're in that ring zero, so to speak. That also means that we are now available in all 50 regions, all 50 public regions, and we also have full availability zone support wherever Azure has that compatibility set up. So are you familiar with Azure's definition of availability zones? Have you interacted with that? All right, I see a few nods in the audience. So what exactly is availability zones for Service Bus? Now, this is a premium-only feature. When you actually enable a Service Bus premium namespace with availability zone support at the time of provisioning, what we do is for premium namespace, because we have 3 copies, we will essentially designate 1 primary and 2 secondaries and have them essentially distributed across different availability zones in the same data center region. So this provides you fault isolation within the same data center region and not across data center regions. So if there's any kind of utility fault, network fault, someone cuts off the wires, the electrics just fried in one of the data centers, at that point, if your primary ever fails, one of your secondaries will be promoted to primary, and all this will be completely abstracted from your namespace or from your client applications. So you will never see a drop in availability of any sort. Life just goes on for your client applications as if nothing happened. Even when you send or receive data from your entire premium namespace, all this will be synchronously replicated across all 3 instances. So you will never see any kind of availability fault. Now that's when it's in the same data center region. What if you want to have fault isolation across data center regions? So for that, we have our geo disaster recovery, which essentially allows you to pair 2 independent premium namespaces in different regions and then have fault isolation across them in case something happens in your primary region. So the flow is comparable. You think of the primary namespace. You provision a secondary namespace in another region. You pair them 2 together so that their metadata is always in sync. What this means is any of your queues, topics, subscriptions, anything you create either at the time of provisioning or at the time of runtime, your application connects and makes a bunch of management calls. Those will always be replicated across your primary and secondary namespaces in real time. In the event of a disaster, which you define for your application, it need not be like the entire data center region goes down. It could very well be for your application that, hey, I can't connect to my namespace for 10 minutes. It's a disaster situation for me. You have the manual failover control in your hand. You can trigger off the failover, and when you do that, the connection string that initially pointed to your premium namespace will now, or your primary namespace will now point to your secondary namespace. So, all your sender and receiver applications will automatically disconnect and reconnect with your secondary namespace, and things go on. So I know what you guys are thinking. What's the next step for this? The next step is, because this is only metadata sync, we also will be expanding to data copy. That's going to be coming soon. And that'll provide you a recovery point objective as opposed to a recovery time objective that the current GeoDR mechanism will provide. All right, so I think I can read your mind. Everyone likes these features, but you may have already been using your standard namespace and kind of ship the solution off in a location that you cannot go ahead and make that upgrade. So you're looking for a way to upgrade your standard to premium namespace, looking to upgrade your standard namespace to premium and leverage all these high availability and disaster recovery solutions. So what do you do about that? Well, I finally have a solution for that. We have a tool which we shipped about 3 weeks back that allow you to do an in-place upgrade for your Service Bus standard. Now the mechanics are comparable with what you saw in the GeoDR, but the way it works is that your standard namespace, you have a connection string that points to your standard namespace. You will create a brand new premium namespace in the same region. You can link them 2 together so that your metadata is copied over. So any kind of queues, topics, subscriptions, filters, etc., it's all moved over. And when you actually go ahead and complete your migration, the connection string automatically points to the premium namespace. How is this in place? It's because no configuration changes are needed. And what does this mean? Your applications, when they're connecting to the standard namespace, at that time, once you complete the migration, they will disconnect and then reconnect to the premium namespace. So how does that sound to everybody? Are you going to take my word for it, or do you want to see a demo? All right. Thankfully, I do have a demo. It's recorded, but let me set it up for you a little bit. So for the purpose of this demo, I wrote 2 very simple Java applications. I set it up until this point, where my standard and premium namespace have their metadata synced together. I go ahead and start my receiver and sender applications just to show that you can actually do this while your applications are running. And once I feel like we have critical mass on the metrics and everything's showing in terms of what messages are being sent, I go ahead and actually complete the transaction or complete the migration, and then you can see the traffic flow into the premium namespace. All right. So there's no voiceover, but I will talk through it as opposed to dancing while it's happening. All right, so what I do over here is I first start my receiver, which you can see over here, and as soon as that starts, I also start my sender application. And that's my standard namespace out there, along with my premium namespace over here. And what I'm trying to showcase over here is that I had sent 436 and received 435 messages in the past, but you'll see this number keep on increasing because I'm constantly sending more messages and receiving them at the same time on the receiver side. Now you can see the incoming requests increase at this point. And once I get critical mass, basically as soon as this number moves, I'll go ahead and click the complete migration button, which is through a portal tool. And you will be able to see the number actually increase over here, where the current premium namespace only has 0 messages sent or received because no one's accessing it. So if your applications are running, sending and receiving from the standard namespace, and you go ahead, you don't need to pause any application of any sort. All you need to do is pair them together while they're running, let the metadata sync. So essentially the queues will be copied over. And whenever you're ready, you can essentially hit the complete migration button. So that's it. So I actually saw requests coming in. I hit the complete migration. As soon as that's done, there'll be a little time that's needed for the DNS entries to be moved across to point to the premium namespace. But at that time, you will see that the receiver has a little log statement saying that the receiver was disconnected, and I'll actually highlight that as well. But let's give it a couple. All right, so that completed the migration. And now we're just waiting for the receiver to disconnect and reconnect as appropriate. There you go. So the receiver actually disconnected. The sender did not, because when we complete the migration, the redirection happens automatically. So the sender is fine. The receiver, even though it disconnected, it actually reconnected automatically. So that's our client SDK essentially doing the retry logic for us. As you can tell, it's the reason is listed out over there. And very soon you'll actually see the metrics show up on this part, which implies that the migration is complete. Both the sender and receiver are actually using our premium namespace, and life has gone on. Promise I'll change the slide as soon as the numbers show up over there. It's like an action movie. You know the ending, but you're still holding your breath. All right, there we go. In-place migration, everyone. And the rest of the video just sees the message count actually increase, so I'll not wait for the whole thing. All right, so that talks about our high availability stuff. Let's move on to our enterprise features next. So we've been doing some work to essentially integrate with other Azure offerings. And one of the first ones I want to talk about is VNet service endpoints. So this allows you or an IT admin persona in your company to essentially limit the access to a premium namespace, based on a VNet that you've previously set up or specific IP address ranges that you feel appropriate. Even if a client application has the connection string and the SAS tokens and all the other stuff, if they don't fit into that access control list, they will not be allowed to access your namespace. So we have this on PowerShell and CLI and ARM templates, but for simplicity, I'm going to talk about the portal tooling. So in the portal tooling, you essentially go to the firewall and virtual network navigation link out there, and once you're there, you can actually select whether you want it to be for all network and selected networks. All networks means that anyone with the right access tokens can access it. Selected networks mean that only the ones that are listed within this VNet ACL or the firewall ACL will be accepted. So you can pick and choose multiple virtual networks. You can essentially pick or cherry pick IP addresses or IP address ranges, and only those folks will be accepted. If something is not within the VNet, but it fits, if the IP address falls in the range, it'll still be accepted. So it's VNet first and then IP address. But they're both independent. So as long as one of them is satisfied, the access will be given. The next one is managed service identity and RBAC. So this is currently in preview. We're actually working towards GAing this. Should land early July. So that's something that is one of our core customer asks. It gets challenging to manage connection strings, SAS keys, everything from your application config. What you can do instead is essentially leverage Azure Active Directory, set up a service identity, provide a specific role to the service identity. We offer one built-in role, which is the Azure Service Bus Data Owner, or you can build custom roles per your use case. And once that is done, just assign the same configuration information in your app.config for your client, and that's it. It automatically will connect, and it just fits with the rest of the infrastructure. All right, lastly, we have the client and connectors. This talks about all of our client SDK work and all the other ways we are playing well with the other integration services that Azure has to offer. Most of the folks from those teams are in the room with us today. So let's talk about our SDK efforts. We had a major release on our Java and .NET SDKs. This is one where our core engineering team was still involved. So we just recently added management client support, WebSocket support, and transaction support to our Java and .NET SDKs. Our Node.js was just recently made generally available, and Python is on its way. Potentially by this fall, we should have it available for everyone to try out. All of these are open source, of course, and the code's viewable on GitHub, so feel free to engage with the community, submit feature requests as need be, and we actively keep a tab on this. We've been actually forced to do this. All right. Secondly, I'm talking about the connectors and integrations that we're doing with the other services that I mentioned. On the left, we have the Logic App connectors. So this has been there for a while. You can essentially have your Logic App send and receive messages, do management operations to create and delete topic subscriptions. If you have long-running messages, you can renew the lock as you please, and also manage sessions from within your Logic App itself. On the Event Grid integration side, we've had the Service Bus Premium namespace emit events to Event Grid for a long time now. But as of last week, we added Service Bus queues, and only queues for now, as an event handler, and this is currently in preview across both standard and premium tier. So definitely take it for a spin, and feel free to submit your feedback on this. All right, and lastly, we have the Data Explorer available for Service Bus. So a lot of you folks may be familiar with Service Bus Explorer. It's one of the tools that one of our CXP folks wrote. But there was a very massive demand for a platform-agnostic browser built-in tool that enables us to do the same thing. Well, we finally have it ready. It's actually going to land in the next week or so, and it'll essentially live on the portal as within the queue or the topic entity. So what operations are we supporting right now? We can send, receive, and peek from a queue. We can send to a topic, receive from its subscriptions, and you can also pick the dead letter entities as well. So I'm not going to walk through each of the flows. For Data Explorer, we can look at the receive one over here. So this is the actual portal screenshot, the way it looks. What you do is you essentially pick the queue, go to the Data Explorer on the left navigation pane. You can see the message statistics. You can pick what operation you want to do. You can identify whether you want to do it on that queue itself or its dead letter entity. You can list all the messages that you're looking to do. So this is specifically for the receive operation, I suppose. The same thing applies for peek as well. And at the same time, you can also click on it to see the actual message contents. The same applies to the topic as well. Again, I'm doing the receive operation over here. You pick the topic, pick the operation. So if you want to send, you will send to that topic itself. If you want to receive or peek, you will then have to pick the appropriate subscription. Once that's done, you can actually see the message stats, which are updated when you pick the subscription, so you know exactly what you're looking at. You can, again, pick the subscription or its dead letter entity, and then you can also look at the messages and look at the message body. All right, some additional updates. Thank you. All right, and lastly, we expanded our premium message offering to 8 MUs as well. So now we have 1, 2, 4, and 8. This is, if you have those throughput requirements, you have that option to essentially take in large amounts of data. We're also going to be working towards private endpoint support. This is essentially an expansion of our VNet service endpoints. VNet service endpoints is cloud-focused. It enables you to limit access to your namespace. With private endpoints, you can essentially mimic an endpoint in your local network that will then be automatically forwarding your requests to a cloud-based endpoint. And lastly, we also will be adding BYOK, support for encryption at rest. As Dan mentioned earlier, we do have encryption in transit with TLS and at rest with a server-side managed key. We'll be expanding that functionality to allow you to bring your own key, put it in Azure Key Vault, and then leverage that key for your encryption at rest. All right, with that, I think I'll leave some time for questions. That's all the updates that we have for Service Bus for now. Any questions in the room? All right, I will yield the floor now. Oh. Not at the moment. Yeah, I mean, the idea is to essentially give the folks maximum control over what data, so they can cherry pick exactly what they want to throw away and what they want to keep. Purge is, I mean, it's been a requested feature, but at the moment there can be a lot of misfires that are tough to recover from.
It's dangerous.
Yeah, because we optimize for persistence, so the issue is that if you end up purging and we hack that, there's no way you can get that message back. All right. Thank you, folks.
Covey.co